Okay, this problem asks us to select one or more expressions that together represent all solutions to the equation. Your answer should be in radians. And we notice that the equation is sine of x equals negative 0.25. So we can start off with using our calculator. We're trying to solve for an angle, so we're going to use second sine on our calculator, and then we're putting in our answer, which is negative 0.25, and we get an answer of negative 0.252. So if we look at our answers over here, we've got a couple of those that have that, two in fact, that have that as a possibility. So we know for sure that one of our answers is going to have negative 0.25 in it. So we know that. But now we need to think about the sine curve itself. To the right here, this is called the unit circle, which I assume you've seen before. And I want you to notice a few things about the unit circle here. Notice up here at the top that it says cosine, comma, sine. That means the first coordinate is always the cosine of the angle. The second coordinate is always the sine of the angle. And if you'll look around the circle, you'll notice something. You'll notice that this and this are the same thing. And most of our angles on here have two values for the sine every time. So then the sine of 11 pi over 6 is negative 1/2, and the sine of 7 pi over 6 is negative 1/2. So then we've got one answer here of negative 0.25. How do we get the other one? Well, we know that in the first quadrant, that's up here, all the trig functions have a positive sign, and in this quadrant, the sine has all positive answers. So that means to get a negative answer, it's got to be in quadrant 3 right here, or in quadrant 4. Well, negative 0.25 is in quadrant 4. If you remember with angles, we typically start measuring at the positive x-axis right here, and if we're moving in an upward counterclockwise direction, that's a positive angle. Since ours is negative 0.25, we're measuring downward from there, probably somewhere along right in there. So you can see, I don't know what that number is, but approximately negative 0.25 would be the sine of it. Well, if you can imagine taking that line now and flipping it across the y-axis, we get a similar line over here. Well, what's going to be similar about this red line that I drew and the blue line? The distance from here to here is going to be 0.25. Well, what we're looking for though is the actual distance from, if we were measuring it from this line all the way around to here. How would we get that number? That's the question. Well, if we stop and think for a second, if we're measuring from this line all the way over to here, that's pi units. That's what we're told right here. And we know that measuring back from pi to our red line is 0.25. So the orange line, the line that we're looking for, must be pi minus 0.25. Well, if we do pi minus 0.25 on our calculator, that's second, the up caret sign for pi, minus 0.25. We get 2.89. Now if we go back and look at our answers, we have a 2.89, it looks like, for F, and we have a negative 2.89 for A. So it could be one of those. Should it be a positive or a negative? Well, what direction did we measure from? We started at the positive x-axis. We went in a clockwise direction. Remember, with trig, a clockwise direction on the unit circle means that it's negative. So then our second answer is negative 2.89. So we've got from that it looks like A might be an answer, B could be an answer, C could be an answer. Assuming our negatives are right, D, E, nor F can be an answer. But what does this n times 2 pi at the end of it mean? Well, I want you to look at what the sine curve looks like. This is the sine curve right here, and notice that it is cyclical. By that I mean if we start right here at 0, and then we go again all the way over to 2 pi, which is right here, that's one cycle. And if we move out to the right, we see that that cycle keeps repeating itself. We go from 0 all the way to 2 pi. I think I can actually trace that out maybe on here. But I can't, so I'm going to go from 0 to 2 pi all the way out to here, and I'm back to the same point. When I go 2 pi units later, I'm back to the same point. If we look at these high points up here, pi over 2, that's 2 pi away, I'm at the high point again. 2 pi away, I'm at the high point again. So what that means for our answers over here is that if I start at negative 0.25, anytime I add an integer times 2 pi, I'm going to be back to the same point. So if n is 0, I'm at negative 0.25. If n is 1, I'm at negative 0.25 plus 2 pi. And we could figure that out on our calculator. If n is 7, I'm at negative 0.25 plus 7 times 2 pi. So that gives us a whole family of answers that I'm going to get. By the same token, negative 2.89, I can add n times 2 pi to it. And all of those answers are going to be true as well. So I think the answers, if I were giving this, the answers I would mark right would be A and C on this. I'll be interested to know if you mark those answers, what solution you get, if they say that's correct. If it's not, I definitely would like to know so that I can go back and figure out what I did incorrectly so I can hopefully guide you to the right answers there. I hope this helps out. I hope you have a blessed evening.